In this video, we are going to study about the circular permutation. And in circular permutation, we don't have beginning and end. So this affects the number of permutations here. If we have linear permutation, if we line up something or if we build up the books, that kind of things, we were using, if there are n elements, n factorial for that one. But for the circular permutation, for this question, it is 5 curves. It says sit around the circular table. When I say for the 5 curves, when I draw this table here, when I say this is, let's say, in the girl 1, and there are 5 curves sit around the circular table, 2, 3, 4, and 5. Now the question is, for the lines, we have beginning and end. For the circle, do we have this one? The answer is no. So we don't have beginning and end. That's why we should find a point that's going to be the beginning or end for the question. For our order. Here, the first person or the fifth person or the fourth person, whichever you want, you can choose that person. And let's say this is the fixed point. If this is the fixed point, this cannot change. So if this cannot change, the rest of the others, they should change. So if there are n terms in the circular permutation, n minus 1 factorial different way, you can order the things. Here there are 5 people, so 5 girls can sit around the circle table. 5 minus 1 factorial different way, that makes 4 factorial. Then that's equal to 4 times 3 times 2 times 1, which is equal to 24 is going to be. Okay. If we solve another example, around the circular table, 2 parents and 4 children, they sit if the parents together. So when I make one circular table here, here the parents sit together, parent 1 and parent 2, let's say they sit together, that's why I draw closer, and there are 4 children, so child 1, child 2, child 3, and child 4, they're going to sit like this. So if we group them, they're going to behave as one. That's why this is going to be one person. So around the circular table now there are normally 5 persons. If there are 5 persons, how many different ways we can order this one? If we ask this question, the answer is going to be 5 minus 1 factorial different way we can order them, which is equal to 4 factorial. It's going to be. If we fix this point, there are 4 the rest. But here we have one more extra here. We have grouped element. If we have the grouped element, this is not put around the circular table. That's why it has beginning and end. So this is going to behave as linear. This is going to behave as linear function. So 2 things can be ordered in 2 factorial different way. That's why it's going to be it's going to be equal to 4 factorial times 2 factorial. You know 4 factorial is equal to 24 from the previous question, and this is going to be 2, so the answer is going to be equal to 48 for the question. Okay, now in this question there are 3 groups: Turkish diplomats, Kyrgyz diplomats, and Turkmen diplomats, and they are sitting around the circular table, and the groups, they sit together. So if there are 3 groups here, we can say like this: totally we have 3 persons here, 1, 2, 3. So these 3 persons can sit around the circular table 3 minus 1 factorial different way, because they behave as group, like in the parent example. In the parent example, I count this one as 1 person, 1, 2, 3, 4, and 5 I said. So 5 minus 1 factorial different way, they can sit. Okay, then 3 minus 1 factorial different way, they can sit. So there are 1, 2, and 3 group of people. Then these 4 people can sit 4 factorial different way in their group. It has beginning and it has end. So they can sit 4 factorial different way in the group. It has beginning and end, so the Kyrgyz group can sit 5 factorial different way, and the Turkish diplomats, they can sit for 3 factorial different way around the circular table. So the answer is 2 factorial times 4 factorial times 5 factorial times 3 factorial. It's going to be here. I want to write the 4 factorial is order between Turkmen group. It's going to be, and here the 5 factorial order between Kyrgyz group. It's going to be Kyrgyz group. It's going to be, and 3 factorial order between Turkish group is going to be. Okay, so 2 factorial is the order between the circular table. Going to be. Okay. Here, how many different way 3 girls and 3 boys can be seated around the circular table? Here, if one boy, if no 2 girls must fit together, means when you put them around the circular table, let's say this is girl 1 here, girl 2 here, and girl 3, if they sit here, they are going to, here the boy 1, boy 2, and boy 3, they are going to sit here. So 2 girls must, no 2 girls must sit together, means girls cannot sit together, and boys, they are not sitting together. 1 boy, 1 girl order it's going to be. Okay, now I'm going to, this question a bit different than here. We are going to fix and 1 point again here, but when you fix 1 point, if this is the girl here, this girl, then the other 2 girls, they can sit around the circular table 2 factorial different way, which is 3 minus 1 factorial, different way. Girls can sit around the circle table. Then boys left. We have beginning and end of the table. That's why these boys and these boys can sit around the circular table 2 factorial different way. So the answer is going to be 2 factorial times 3 factorial, which is equal to 2 times 1 times 3 times 2 times 1. It's equal to 2 times 6, which is equal to 12 different way they can sit around the circular table. Okay, in this question we have red bit and blue bit, green bit, pardon, and yellow bit. Arrange the necklace. I already arranged the bits here before to show the explanation here. For this kind of necklace, and that can be seen from both sides, the things that can be seen from both sides, we are using n minus 1 factorial, this is circular permutation, over 2 formula, because this kind of things can be seen as from both sides. I'm going to explain what I mean. So the answer of this question, it's going to be equal to 4 minus 1 factorial over 2, it's going to be, and it's going to be equal to here 4 here 3 factorial times over 2 factorial, pardon, over 2, 3 times 2 times 1 over 2. The answer is 3. Here, as you see, I draw 6 different figures, because when we look at the thing, n minus 1 factorial, it's going to be n minus 1 is equal to 3 here, 3 factorial different way, the answer must be equal to 6. But I am going to prove that the first one and the third one, or one of them here, they are going to be same. Now I'm going to copy the first one, and I'm going to flip this one. I'm going to flip this one. Yes. Flip with respect to x-axis, with respect to y-axis. Yes, I'm going to flip with respect to y-axis. Now I flip this one. The same figure, again I'm doing with back undo. It was like this. Now I flipped and I brought in this one. It was in this form and I flipped and the blue one passed to other side. As you see, the blue one on this side, blue and red on this side, and when you send, it becomes on the left side. So as you see, here it's going to be in this one. Okay, now the order is red, then blue, then yellow, and then green. These are the first three, and I need to find the order like this. But here, when I move this one, okay, this is the, I couldn't find maybe here the same one, but when I rotate this one like this, as you see, this one, which is the first one, also same with the fifth one. So here the three of them has the same looking from the other side. That's why we are dividing by 2, and the answer is going to be 3 factorial. Okay, in how many different way? 6 different keys we can put on a ring. Here the answer is going to be, as you understand, 6 minus 1 factorial over 2 is going to be, which is equal to 5 factorial over 2. 5 times 4 times 3 times 2 times 1 over 2 is going to be, and the answer is 5 times 4, 20 times 3, 60 is going to be. So 60 different way we can put on a necklace.